All right, I'm going to show you how to solve multi-step equations with variables on both sides of the equal sign. All right, so we're going to start off with 5x plus 2 equals negative x plus 14. So you want to get the variables on one side and the numbers on the other. So we're going to add the x to both sides. And we're going to get 5x plus 1x, which is 6x, plus 2 equals, this zeroes out, and that's a positive 14. I'm going to subtract the 2 on each side, and we're going to get 6x equals 12. We're going to divide by 6, and we're going to get 1. And x equals 2. You can easily go back and check. 2 times 5 is 10, plus 2 is 12, so you got 12 on the side. Negative 2 plus 14 is 12, so it checks. So you can do that pretty quickly without writing it out also, but you should check just to be sure. All right. Here's a problem where you have variables on both sides, but you have to combine like terms on the same side. So negative 26 plus 5 minus 3k equals 18k. So in this case, you want to combine like terms. So negative 26 plus 5 is negative 21. Bring down minus 3k equals 18k. Now we're going to add 3k to both sides. It's all right if your your variable is on the right-hand side versus the left-hand side. It doesn't matter with equals. It's perfectly fine. So that zeroes out. Negative 21 equals 21k. All right, so now we want to divide by 21 that's next to the k, because you're trying to get k by itself all alone. So this is negative 1 equals k. Or you can write it as k equals negative 1 now. But keep the variable on the left side or the right side of the equation based on where it is, and it's fine. So this time it's on the right, leave it there. So you want to be flexible enough to work with it this way. Right, next, we have some distributive property with variables on both sides. All right, so we have negative 18 minus 6k equals 6 times the quantity of 1 plus 3k. All right, so we've got to distribute first on that side. So we're going to rewrite our problem as negative 18 minus 6k equals 6 times 1 is 6, and 6 times 3k is 18k. All right, and so now what we're going to do is we're going to get k on one side, numbers on the other. So in this case, I'm looking at this negative 6k and the 18 is positive. So I'm going to bring the 6k over to my right-hand side. I kind of like to keep my variables positive if I can. So that's going to go to 0, giving me negative 18 equals 6 plus 24k. So that means now that I got to take this positive 6 and I have to move it to the other side by subtracting. That's going to go to 0, and I'm going to get a negative 24 equals a positive 24k. All right, again, we have our variable on the right-hand side, which is fine. We want to divide by the number that is being multiplied by our variable. So we're going to divide by 24 and divide by 24. So this is going to be negative 1 equals k. All right, or you can now rewrite it as k equals negative 1. Okay, now I'm going to give you a bigger problem to deal with where you have distributing and combining on both sides of the equation. So first, we always distribute. Multiplication occurs all the time before we add or subtract any terms. So we're going to get 2x plus 14 minus 34 equals, this is still 4x, this is still minus 11x, this is now plus. This is 4 times the quantity of x minus 1. So 4 gets multiplied by x, and 4 gets multiplied by a negative 1. So that becomes plus 4x minus 4. Now all your multiplication or distributing is done. Now we can combine like terms. Okay, here's our equal sign. So we have a boundary. On this side of the equals, we can combine positive 14 minus 34. So we're going to get 2x, and this becomes minus 20 equals. On this side, we can combine 4x minus 11x first, which is negative 7x. We still have plus 4x, and we still have minus 4. Okay? So now we can combine negative 7x plus 4x, which is going to give us negative 3x minus 4. Or if you could do this in your head, which is fine, 4x minus 11x, negative 7 plus 4x is going to give us then the negative 3x. All right. Now we can bring our x's to one side, numbers to the other. Since 2x is positive and 3x is negative, I'm going to bring the 3x to the left-hand side this time. That will zero out. And we're going to get 5x minus 20 equals negative 4. And in this case, we're going to add the 20 to the right-hand side. And we're going to get 5x equals negative 4 plus 20 is 16. All right, so now we're going to divide by 5. Divide by 5. That's a 1, so x is equal to 16 over 5, or it equals to 1 and, oh sorry, 3. My mistake. 3 and 1/5. You can leave it either way. Or x could also equal 3.2. So any one of these is perfectly fine answers. So 16 over 5, 3 and 1/5, or 3.2. All right, now we get into two problems that are our last problems that are a little tricky. We've been able to find a solution for the variable. We only get one answer. But what happens if we lose our variable? All right, so let's look at this problem. All right, so we have x plus 5x plus 4 equals 6x minus 3. On this side, we combine like terms, and we get 6x plus 4 equals 6x minus 3. So we start our business, and we start to subtract our variables from both sides. So we subtract our 6x. And what we're going to notice is that the x goes away. It disappears. 0x is still 0, so the x, the variable, is gone. So we lost the variable. It's gone. So what we wind up with is 4 equals negative 3. So now you have to ask yourself, is this true? All right, so whenever you lose the variable, is this true? And the answer is no, it's false. Okay, 4 is not equal to negative 3. So the answer is no, it's false. When you lose your variable and the numbers that are left are not true, the equation is not true, then it's false. If it's a false statement, then you have no solutions. And that's your final answer. So again, when you lose the variable in the equation and you cannot solve, check this statement, this equation, and if it's not true, if it is false, there are no solutions. Well, the opposite can happen. What if we lose our variable and it becomes a true statement? So let's take a look at 8 times the quantity of x plus 2 equals 8x plus 16. We distribute first, and we wind up with 8x plus 16 equals 8x plus 16. Well, right here you can see it's a true statement, but some of us don't pay attention to that. You know, kids, we start doing the work, we become robotic, and we just do this, right? And we say, okay, that's gone and that's gone, and then we wind up with, hey, 16 equals 16. We lost the variable again. All right, so what we have to ask ourselves, if we didn't notice here that this was true, it's the exact same thing on both sides, and we wind up down here, and we lose our variable, okay, then we have to say, is this true or false? Is 16 equal to 16? Well, it's true. And when this is a true statement and we have lost our variable, then we have infinite solutions, which means all real numbers will work for x. So x could be any number. It could be -1. It could be 100, and it will always make this a true equation.